lesson 6.2. We will continue to use this customers database. And the customers database has more to it than just customers. And I think the customers are not people, they're businesses, right? So they're businesses ordering products from suppliers, and there are shippers involved in moving those items from one place to another. So we have these various tables that are tracking the different aspects of this network. But ultimately, it's kind of about the customers and the products that they receive. So we can start to ask some questions about that. Now, I want to show you a little bit about how the database is actually built. In real life, you would probably be given a connection string, some kind of credentials to access a database, and then you could start to work with it. Sometimes a database exists as an external file, and you can connect with that through using Python. But that process is kind of annoying in Google Colab. It involves a lot of steps, and we have to enter our Google credentials and everything like that. But you can also create a database directly within a Python program. So that's what I've built for you here. And all you have to do is click this play button to run the code. And if you want to see the code, be careful because it's a lot. But you can click to show the code and see just a little bit about how the database is constructed. So we start off by importing the SQLite 3 library. I'm going to say just a few words about this, and then we'll leave it behind. We can then create, basically we create this connection variable, connection to the database, and this database customers.db is being created right here in this line. So that's going to the server that is supporting this Colab notebook. So it's being stored in memory while we have this session running. There's another aspect that we are going to care about. It's called the cursor. This is a variable. Usually when you're working with databases, you have something like this, and you think it's very much analogous to an actual cursor, where we use it to click on something and make something happen. So the cursor is telling the database what to do. And here's how we can create a table. These 3 quotation marks that allows us to do what's called a doc string, and a doc string lets us write our commands on separate lines, not all in one long line. Okay. We're also going to use this execute command quite a bit, and that's going to be how we run queries in the SQLite database. Okay. So execute cursor. So we'll reference the C variable a lot. Now I'm going to collapse this, and I can do that by double clicking on the white area. Okay. So we're about to investigate this database and use some of our Python tricks along with the data that is produced. So this would be a really good time to make sure you have lesson 6.2 open, and I would say save it to your Google Drive so you can follow along. And the very first thing to do will be to run this code block. I hope the arrow made it clear. And the first time it runs, it's going to take a really long time, and you only want to run it once per session. So I probably already ran it. And I think that's going to be okay. I was just about to. Okay, so I did already run it. So if you already ran it and then you run it again, it's okay, because everything is stored and you won't override anything. So once we have that, we can move to our preliminary remarks and just reference again how we're going to run our queries. C is the cursor. We'll always reference C when we want to do something in the database. Execute is how we make something happen. We're also going to have this other method, which is the fetch method, and there are three options. This is how we can take a look at any records returned from the database. So it's going to behave a lot like what we see here. When we run a query, we're going to see some records come back, and we'll be able to, these are the records, right? So the records are identified by the customer ID. So for customer name is Around the Horn. Sounds like fun. Sounds very British, doesn't it? And we can just repeat this query and get the same information back using Python, but it's going to look a little bit different. We have to run the execute and then the fetch command to see the results. And we'll often use the fetch all. So when we click the button in the W3 Schools tutorial, it's kind of like doing this fetch all step to show us everything. These are not critical, but I wanted to include some code so you could see how we could take a look at all of the tables in a database and how we could look at all of the columns in a particular table. So this is something I just had to research a little bit and see how this is done in SQLite. And I just followed the code and linked to the source. One thing that we can start to do is we can start to see these queries. So if I run the select all from categories, what I get back is an object, a Python object that looks very much like a list. And it is a list. It's a list of tuples. Okay. So I'd like to take a second and make sure everyone can get to this point. We'll get the database running and we'll do one select all, and then we'll start to go through some examples while adding some extra Python tricks. Okay, cool. So let's just try running some queries. In the homework assignment, you'll see similar queries. So what you'll want to do is probably go back and forth between these notes and that assignment to help yourself learn the commands. And you'll see that in a lot of cases, we're just modifying one small aspect of it. So the assignment problems will be things like select all the customers from the city of Madrid, right? So it's a different type of filtering, but same idea, okay? That way we'll kind of ease into this. Okay, now working with this output, when we get back a data object from a Python operation, we always want to understand that object and how to work with it. So this is a list of tuples, and it would be helpful to think about how we might access specific information. We could do a lot with a query. We can make a really specific query, but we can also get even more specific information by using some of our really basic Python operations. So for example, I might ask you to try to figure out how to access, like how would we access just the country from each of these tuples? Let's think about that for a second. The list is called G, right? If I want to, and I'll remind you that a tuple behaves like a list in terms of indexing. So remember how we practiced, indexing, nested data structures. We're going to do a lot of that same kind of thing here. So we have a list, and the first tuple has 1, 2, how many indices? 0, 1, 2, 3, 4, 5, 6. So the item at index 6 is the country, right? But I could also do, remember how to access the last item in a collection with an index? Yeah, we could do that. We could do -1 also. So we're going to be working with this a little bit. So just to convince myself that this is actually a list of tuples, I kind of like to check, well, okay, what do I get back when I run this query to the database? I get a list. What is each item in that list? Okay, it's a tuple. I know how to work with those. I work with them a lot like I do lists. It's just the difference with a tuple is I can't change it the way I can change a list. Okay. So here, if I wanted to use Python to access something more specific, I could use index 1. So let's take a second to make sure you understand where this is coming from. So for I and G, G is the collection of the customers returned. I want I at index 1. So do you see where that's coming from? If you scroll up to the data object, you can just take a minute to make sure you follow that logic, right? Makes sense? Yeah, so it's the second item in each of the tuples. Okay. Okay, a couple of more different types of queries we can do. I can just select the addresses from customers where the country is Germany. So again, I can be more specific with the query to get something back that's more specific. Here's a place, you'll see this in a couple of the examples where I'm adding some extra code that you're not going to be held accountable for. But I wanted to give you a little bit of a preview and give you a sense of what might be done with data that comes back from requests to a database. So if I were doing this, I might be thinking about how to format the output a little bit differently so that I could be presenting it, right? So we are going to be using a library called Pandas. Have you used, oh no, you're not using that, right? You're using NumPy. I remember now. But we will use it. And within Pandas is a function called data frame, which basically creates a structure that looks a lot like an Excel spreadsheet. And it's an object that has a lot of really useful attributes and methods. So we can do things like find statistical summaries and easily with one click and things like that. So if I were asked to find all the addresses in Germany, I might not want to just tell my supervisor, okay, here it is, right? I might want to do a tidier data summary. And I can do that with the Pandas data frame option. So just showing you a little bit of what's possible there. Okay. Another query we could do is to select all the products with a different filter to see prices that are products that cost more than $10. Okay. So we get that back. Now, what might we want to do with something like this? And can you figure out what the index of the prices are? If you look at the tuples in the list, the prices look like there's a last item in those tuples. So what's the index for those? Yeah, we could do -1 for that. So 0, 1, 2, 3, 4, 5, or -1. Much easier to do -1, but I was slow to figure that out. So here's another trick I wanted to share with you while we're at it. Another thing that you are not held accountable for, but a tool you could use if you want to take some time to figure out how it works. If I'm dealing with some quantitative information, then I'm probably going to want to do a statistical summary. And two of those statistical measures might be the mean and the median of all of these prices that are returned from the query. So I know how to do that with NumPy, I can import from NumPy, import mean and median. And then here's where I use the mean function. Here's where I use the median function. I shared with you a little bit of extra code to show the format method and how that could be used to create a nice looking output. So no need to learn this unless you're interested. And the format method is linked right here. But that makes it easier to output the results. So the mean, this is informative to me because my background in statistics tells me that there are just a few really high priced items, but most of the items are closer to 22. Always a good idea when you have a big difference between the mean and the median to report the median because it's better representation of a typical value. Okay. Next we have, whoops, this was supposed to be market. All right, so I wanted to try a selection that involved looking for a substring, so a portion of customer's name that contains the word market. And so I get a few, some of them look like they're in French, other languages, maybe. Here's one, okay. So once again, I think I want to make this into Pandas data frame. So what am I doing here? What am I getting with this I brackets 1 and I brackets -1? Where is that coming from? The market data is the list of tuples. So once again, we have the name of the customer and the country. So I'm using Python again to get something a little more specific, and then using this Pandas data frame function with column names, making it look really nice. Okay, that's another thing we can do. Here's a fun one. I can run a query to select all records from the orders table, and then I can order according to order date in the ascending direction. So this would give me records that start with the earliest order, 1996, July 4th of July. And then they go in ascending order. So they go up to, I think they go up to dates in 1997. Okay, so I could do a tricky query, but I could also do this probably more easily in Python. What if I just wanted to see the orders from July 1996? I thought about this and I thought, yeah, this is something I maybe have had to do in the past, where I had to use Python to get something more interesting from the results. So I could set up a list called July 1996. I can iterate through the list of orders that's in ascending order. That doesn't really matter anymore, but I guess because I have them in order, I probably could just leverage that to find all of the ones from July 1996, or I could do this. I could do if, and this is referred to as a substring. If that's in I3, well, what's I3? So I is 0, 1, 2, 3. So I3 is the date of the order. Then I'll append that entire record. I'll append everything to the list, and then I'll get those first 5 records from July 1996. Okay. This last example, I know I'm going through a lot of examples. I think I'll leave this one to you so I don't talk through it because it's too much talking, but just a quick summary. A goal that might be interesting is to figure out which customers submitted the most orders. We can write a basic program in Python to do that. And we can figure out what is the maximum number of orders, and we can figure out what customer corresponds to the maximum number of orders. So here's a couple of for loops to do that. So just a lot we can do with Python, where we query and then analyze the results of those queries using Python. At this point, I think it would make a lot of sense to give you a chance to kind of soak in all of these examples and